Hi, my name is Megan Rush. I am a RAPS Watershed Coordinator with Lower Kansas River Watershed. And in this watershed we are addressing an impairment of bacteria, or a high level of bacteria, on Stranger Creek and all the tributaries that lead into it. Ways that we address that are through livestock management. That can be through grazing cover crops in the winter, spreading the manure out on the field, relocating feeding areas away from streams, and also what we're going to be going over today, alternative watering systems or off-stream watering systems, so the cattle aren't going down to the creek to get a drink of water. First, we were going to have a permanent watering system out here, and Will Boyer, watershed specialist with K-State Extension, designed this project, but the landowner is a full-time employee also, so we came into a time crunch between when the cattle would be grazing the cover crops and when we needed a watering system set up. So Will Boyer came up with this design for a low-cost alternative water that was going to be temporary. After Will explains the components of this project, I'll explain how it's turned into a more permanent solution for him and the success of the project.
Will Boyer, an Extension Watershed Specialist for K-State and a service provider for the RAPS program in Northeast Kansas. As Megan mentioned, we're looking at more of a permanent and long-term solution originally with the cooperator here, and it was going to be relatively expensive compared to what we ended up with. And that involved pumping water from a well to a storage tank over there on that little hill to my right, and then gravity feeding the water into a water that was somewhat buried in the ground. And instead of getting too deep into that before, we'd been challenged already by our folks at KDHE to come up with some less expensive solar water pumping systems, because previously our solar pumping systems were being cost shared at anywhere from $3,000 to $5,000, maybe even more for a more complicated system. And we knew that with a little bit of self-ingenuity and helping the producers assemble some of the components that go into it, we could do it for a lot less. So that's kind of how we decided to put a pause button on that more advanced pumping system and storage system and try out this with the less expensive components. Instead of coming up with this system to pump water up to a hill and let it drain back down to a tank, we decided we'd try to make use of this well. The producer also identified another well that we might be working with as well. It's a hand dug well, and it's not very deep, probably 15 feet or so. I don't remember exactly. But for pumping out of a well like that, or we can talk more about pumping out of a stream too as we go on in this presentation. This little pump looks kind of like a sump pump, but it's a 12-volt system. It has a centrifugal impeller in the bottom, which makes it ideal for doing this in the wintertime. And for shallow lifts like this, it works really well. Anything over, I think they said 26 feet is what you can expect to get for water lift on this. And at that 26 feet, you'll probably get like 20 gallons a minute or 15, and maybe at lower lifts it would be up to 25 or 30 gallons a minute, which is a great amount of water. Really more water than we would need for this system, because we're only watering about, I think around 25 head here. So this is the pump that we're working with. We attached just a basic garden hose to the end of it, and you can see that there's some extra garden hose sitting here. That was a 50-foot garden hose, and we cut it to the length we needed, and you can see there's a constant slope coming out of the back of the tank there, and that's important. We'll cover that some more when we get into the freeze-proof elements of this system, and that fact that this is a centrifugal impeller that has no diaphragms in it makes this kind of a pump ideal for this kind of winter watering system. So that's a well pumping system. It's powered by a 12-volt battery that actually has a solar panel and a charge controller on the back of it. For just the solar panel and the charge controller, You're looking at less, this is a 100 watt solar panel. You're looking at less than probably about $100, maybe even a little bit less in today's prices. So just for the charge controller and the panel. Some of the electronics with this system get a little bit complicated in that you have to have a method to make sure that you reduce your amperage enough to allow the system that's sensing the change in water level to be able to handle that amperage. In this case we used a 12 volt solenoid like would be in an older like 1970s model cars. We also needed some sort of a system to actually detect the water level change in the tank. So this wire goes all the way to the tank, and there's a 2 wire it's sticking in the water when the tank is full, and it senses the water level, and when the water level goes down, it senses the loss of continuity of the current of the circuit through the water. Relevant factor to all this is the angle of the solar panel and the mounting system, and I mentioned we're trying to do this for low budget, so we're just using right now just some PVC pipe, which is relatively inexpensive, easy to work with. A couple U-bolts and some PVC pipe, and just through friction we can adjust the angle of this panel, which in the winter time, which is when we were using this in the fall and winter, the ideal general setting for the panel angle is 15 degrees plus our latitude, so we had it somewhere close to 55 degrees. And then in the summer, if you wanted to use it in the summer, you can adjust the angle of it to meet the needs of the summertime angle, which would be 15 in midsummer would be 15 degrees minus the angle, which would give you 25 degree slope. So this whole system here has its own battery, its own solar panel and charge controller, and this advanced power electrical continuity sensor. So this whole system is strictly just here to power the pump and turn it on and off when the water level changes. As I mentioned a little bit ago, we were dealing with challenges of freezing water in the wintertime, and that can be pretty challenging. The fact that we have a well helps out, as I mentioned. The ability for that centrifugal impeller in the bottom there to spin freely as the power is shut off allows the water that was in the hose to drain back down into the well. So that way we don't have water in the hose freezing up and stopping the works. We also have to be able to deal with the fact that that 2-prong continuity sensor is going to be in ice if we don't do something with the freezing water in the tank. Now the producer went way beyond what lots of people do, and it was really great to see him so enthused about putting insulation around this tank, and that's helped a lot to make this whole system work without any problems with freezing up. So everything that is here next to the tank is all responsible for helping to reduce the freezing of the water in the tank, and more specifically just the water around that sensor, to make sure that when it gets down to 0 we're still going to have some free flowing water that sensor can work in. And this little 2-pin connector right here we had connected to 2 different things. The air bubbler, which is a little air compressor and an air stone. This really, I don't say like, it's identical to what that you use in some fish aquariums. So this is the little 12 volt air pump, and the little stone that spreads out all of the bubbles and helps to circulate the water and help minimize freezing in the system. Now we also can show people how you can just hook one of these up to a battery without a solar system. So the bubbler is one of the things that we're using this energy for. The other is a self-regulating heat cable, which is wrapped. This is a little bit different, and we'll look at it in a minute. It's wrapped around a pipe like this, and basically what This cable is, I'll give you a better look at it individually here without it being wrapped. It looks kind of like a little house wiring cable, but only, you know, like a third of the size. And within that cable there's two wires, and then in between those two wires is some kind of a carbon substance that allows for more current to pass in between the two wires and generate more heat as the temperature gets colder. So that's what we've tried using to keep the ice off of our sensor. A short piece of 4-inch PVC pipe that has a 2-inch pipe embedded in it with some black insulation around it, the kind of stuff that they use in water gardens to make like rock structures apparently. So it's supposed to be non-toxic and not going to be a concern for the animals. And then in the top of this PVC cap here, the 2-inch cap, is these two wire sensors that are touching the water right now. And I'm going to pull this out, and one interesting thing, and it's helpful to have on this Advanced Powers 2-wire sensor system, there's an 8-second delay, or it may be more like 10 or 12 sometimes it seems. As soon as those sensors come out of the water, the clock starts ticking, and then eventually the pump will turn on, and you can kind of probably see, and now you can hear the water circulating. So when the water level goes down, the contact of those wires become broken, and then the pump turns on. And likewise, there's an 8-second delay to turn it off. And then the other element that makes the insulation important, helps with the insulation, is the fact that we've got well water. The nice thing about well water is summertime or wintertime, it's ideal drinking for livestock. They like that cool water in the summer, and in the wintertime it's like 50 or 60 degrees. So yeah, that's kind of the story we have so far, and Megan, our RAPS coordinator, can add to it if you want to come help me out a little bit. We'll talk a little bit more about how this kind of temporary or to some extent portable system may come into play more in the future as we work with producers in this watershed. One of the key things, both with summertime rotational grazing, and then also maybe just as much or more so with this type of setup where we're grazing cover crop fields, is you want to be able to move your system around. In the rotational summertime grazing, you want to move to different paddocks around, and having lightweight portable material is helpful. In the wintertime, in the cover crop grazing situation, the same field probably isn't going to be grazed every time, and if that's the case, the same kind of watering source might not be used every time. You might be pumping out of a stream at one time, a well at another time, and a pond at another time. But I think we've got some people becoming more interested in what we're doing. This is, like I mentioned, this is really the first year that we've kind of tried to put these systems together in this fashion for people. Previously we were buying more ready-made, higher priced turnkey kind of situations. We were helping people with cost share on those turnkey situations, and this involves a little bit of me or another person helping out, assembling some of the components, finding them, and then letting them provide, you know, the expense related to part of the system, and then RAPS providing the cost share for the expense of the other components.
And so for the landowner here, this situation was supposed to be temporary at first, but it has moved into a permanent solution for him. It meets all of the needs that he wanted for a watering site. So the great thing about working with this landowner is that he's willing to let other people in the surrounding area that might want the same system come and check it out as a demonstration project. And the common question that we get is, how much does this setup cost versus a larger setup? Well, how much do these components cost?
Well, that's something I'm excited to talk about, because as I mentioned, a lot of the things that we were doing earlier, they were running, $2,000–3,000 real easily. And for bigger systems, I think, they could, if you turnkey process it with somebody, it could be $5,000 or $7,000. And we can knock one of those zeros off, which is great news.
So for this project for the landowner, it was meeting all of the needs that he needed for watering cattle off of the stream, and it also met all of our needs for water quality in this area. Overall, this was a really successful project.